Good afternoon, everybody. This is Rebecca Hartley. I'm the Director of Operations for CAVES and the Center for Workforce Development. I want to go ahead and start. I know there will be a few more people join, but we want to get started at 2 o'clock so that we'll have plenty of time for the discussion piece of this, as well as hearing from our speaker. This is the first in a series of webinars for CAVES. So we'll be doing these quarterly. So the next one will be in February, followed by one in May, and then in August. So we'll continue to send reminders and hope everyone can join us as we move forward. But I want to introduce you today to our speaker, Dr. Jerome McClendon, who is a research assistant professor at Clemson University. His appointment is currently in the Department of Automotive Engineering, but in the past, he was also a research assistant professor in the School of Computing at Clemson University. So Dr. McClendon's research efforts lie at the intersection of artificial intelligence and human-centered computing. His research is focused on the design, implementation, and evaluation of intelligent computing systems that mimic human behavior in the following 4 areas of interest: robotics and autonomous systems, conversation or natural language understanding, learning, and decision-making. His aim is to use systems with intelligent capabilities to assist experts from various domains in becoming more effective and efficient professionals. Dr. McClendon has a BS and an MS from Auburn University and a PhD in computer science from Clemson University. We asked him to give a similar presentation for the South Carolina Technical College system early last fall, and so we're happy to have him join as our first speaker in this webinar series. We have some time at the end for questions, but I think he's going to tell you to feel free to ask questions throughout. So we would to be very engaging and conversational. So I'm going to turn it over to Dr. McClendon now and look forward to your feedback throughout and at the end of his presentation.
All right, thank you, Rebecca, and good evening, everyone. As Rebecca said, my name is Jerome McClendon, and today I will be, presenting to you my topic on introduction to machine learning and artificial intelligence and how it can be used to actually shape education. There we go. Rebecca already gave me a good introduction, but once again, I'm Jerome McClendon. I'm a research assistant professor at Clemson University in the automotive engineering department, where I do research in autonomous vehicles. My PhD is in computer science, where at Clemson University, where I focused on how can we use machine learning to actually train nurse practitioners on how to actually interview pediatric patients. So I basically created a chatbot system that would work with nursing students. So jumping right into it. First, I always like to start off a presentation by giving some background information. So first, looking at artificial intelligence. So everyone knows we're now living in the artificial intelligence era. Every time you turn on the TV or you listen to the news or you pick up a magazine or read a newspaper article, you might hear the word artificial intelligence and machine learning. And you hear about all the artificial intelligence, all the different things that it's actually accomplishing. So in this picture off to the right, you can see artificial intelligence actually being used to direct the orchestra. Artificial intelligence actually won at Jeopardy. Or if you go to the H&R Block to actually pay your taxes, artificial intelligence is actually used to do your taxes or to assist the tax agent. And artificial intelligence can now prepare your meal. I even used artificial intelligence to prepare this presentation. So all of my slides that were designed, I got the design ideas from the artificial intelligence agent within PowerPoint. So if the slides look confusing, blame it on the actual machine. So you might have the following questions when you actually see all this stuff about artificial intelligence. What is AI, first of all? What is machine learning? Is it here to stay or is it just a buzzword? And how can you use it? And specifically today, we want to focus on how can AI and machine learning be actually used in education. And I'm going to focus on a few, I guess, use cases in admissions. How can it be used in the classroom, advising, and also the final point, performance evaluation and assessment. And then at the end of the presentation, I'll give one big idea of how I think machine learning could be used to transform education or solve a challenge in our today's society. So what is AI? So I like to define AI is basically software that has been developed to mimic or actually imitate human-like behavior or intelligence. So as humans, we like to think that we're capable of doing three different things. Sensing, so being able to sense our environment, thinking about what we have sensed, and then we act towards some type of goal. And basically, those are the things that, as developers or people in artificial intelligence or researchers, that's what we try to do. We try to create software or intelligence systems that can sense, think, and act towards some kind of goal. And as Rebecca said, please feel free to stop me if you have any questions at any time, even if it's to tell me that, maybe you didn't catch something or I need to slow down. So, artificial intelligence has been around a very long time. It's not anything new. It's been around since I want to say probably like before the 60s. But the first artificial intelligence systems were actually rule-based systems. So a rule-based system you can think of if you're familiar with programming is just a bunch of if statements. And an example of how a rule-based system could be applied to, I guess, current academics is if I had a student take class X and Y in high school, then I would place them in class Z when entering into college. So this was actually hard coded into programs. And some of the early examples of rule-based systems would be like games of chess or other types of strategy-based games. But they also did have like conversational systems in the very early AI system, in our very early AI type systems that would basically ask the user a question, the user will respond with an answer, and then based off of those if-then rules or clauses, the AI will actually respond. But the challenge with rule-based systems, if you want to actually create intelligence, you can't come up with all the possible rules, especially when we're dealing with stuff like natural language, because language is so ambiguous, it's hard for someone to come up with all the rules. Like one example that I like to give when dealing with how hard natural language is as far as it relates to intelligence is, one of the things that we actually say is like, people say fat chance and a slim chance, and that actually means the same thing. And also people may say that this person is a wise guy. That could mean that the guy is smart, or that means he's a smart aleck, he's a criminal. So it's definitely hard to actually understand, language when it comes to machines. And one of the things that you can't do is come up with all the possible rules. So that's when they start moving toward this idea of machine learning. And machine learning, just to summarize, is just a set of statistical techniques for learning from observations. And these observations are what we call a training set, is what we call a training set. And it's just examples that have been collected to give to the machine to actually learn from. So when we actually talk about machine learning, it's different types of machine learning problems, and they fall into different categories. The first type of machine learning problem is classification. So in classification, you're trying to take a known observation or instance and put it or place it or decide which class it actually belongs to or category that it belongs to or membership. So you're trying to decide, if I give you some data point that you may have never seen before, how do I decide what class or category it belongs to? So it's a membership problem. And how can we actually use classification in an example of education? So say for instance, we wanted to determine if you place John Doe in math course Z, will he pass or fail? In this example, if we want to solve this problem using machine learning and classification, we would take a training set, which is just past examples or observations of the students who have taken class Z. The training set may consist of 4 independent variables indicating the past students' average math grade for each year in high school, and a dependent variable which indicates whether he or she failed or passed course Z. And from that, we basically are trying to learn the relationship between some independent variable and some kind of dependent variable. And this is what we will actually call classification. Another type of machine learning problem would be regression. And in regression, we're basically trying to predict the output. And in this case, the output will be some form of real or continuous value. An example of this would be if we want to actually predict John Doe's GPA if placed in course X, Y, and Z in the same semester. So this would be a regression problem because we have some kind of real value. So to do this, we also need a training set of past students who have taken courses X, Y, and Z to give the machine as an example. So the training set consists of past student grades for related courses taken in high school and a dependent variable which indicates their GPA in college when they take courses X, Y, and Z. So we can use this training set and we can basically create a regression model to predict Z based off of the independent variables. To predict their GPA based off of the independent variables of X, Y, and Z. So these are examples in which we actually use a data set to actually do some kind of classification or some kind of regression model to do some form of prediction. But in these examples, we actually need past examples. Well, it's another form of machine learning called unsupervised learning or clustering. And in clustering, we do not need like a training set. We do not need a training set. So in clustering, we're basically trying to group similar objects based off of their statistical similarity. So objects that are similar are placed closer to each other than those in other groups. So an example of this was after the fall semester administration, the administration wants to analyze the performance of the freshman class, but they're not searching for a specific answer, only looking for patterns in the data. So one way they can use unsupervised learning is to actually cluster the students by their GPA, their residence, their semester credit hours, and their program that they're in. From that clustering, we might discover patterns in their actual GPA. So all these are examples of how machine learning or types of machine learning, and then I followed it up with the types of examples of how it can be used in education. Are there any questions so far?
Yes, we have one.
Yeah.
How big of a sample set do you need to have for machine learning to be effective? Came from Zach Trabucas.
So it depends on what type of model that you're training. And for a very basic neural network, you don't need a lot of data for something that's not a deep neural network, which we will talk about in a later slide. But for a very simple neural network or a very simple SVM or clustering technique, usually between in the area of 100 data points. But it's always the more data that you have, the better accuracy that you will get, unless you actually overtrain the system in that point or overfit the system. But usually it's the method that the more data you have, the better the system will actually learn. So for a very simple learning algorithm, I would say in the hundreds, but to have an accurate classification. But for a more complicated model, such as deep learning or deep neural networks, you would need in the thousands. Okay, moving on. So the resurgence of AI. So you may have looked at the last few slides and you're saying, okay, these techniques have been around forever. They seem like regular statistical problems that, people have already solved. So why do I keep hearing the word AI and machine learning? Why is it so much hype and why is it so much buzz around these terms? And that's because of deep neural networks. And also neural networks have been around a long time as well. But because of the advancement in computational platforms, the hardware that we have, and I guess software to an extent, we have been able to, I guess, break some barriers that we couldn't do early on in the machine learning and AI field. And those barriers are in the neural network field. So a neural network is a machine learning technique inspired by our biological nervous systems. So neural network for neurons actually in your brain. So, in deep learning is a set of techniques based on neural networks consisting of multiple neural network layers, which allow the algorithm to learn complicated patterns. So, neural networks are inspired by our biological nervous system, but I like to tell my students when I'm teaching about neural networks that nobody really has an idea of how the brain works. We have a clue, we have a hypothesis, we may have some idea of certain mechanisms within the brain, but we really don't have a definite answer. So this is all inspired by how we think the actual brain works. So deep neural networks are the latest and the greatest technology in machine learning and AI. Everyone is using them, and they have been able to break some records, or not even records. They have been able to achieve human-like performance in some data sets and do imitate humans in some tasks. So if we look at deep neural networks in the vision, we can see that neural networks have been used to classify different objects. So in this picture above, you can see this is an example of a deep neural network classifying this picture that is of a dog and saying that it's a dog, and then of the other picture being able to say that it's a frog. So this is one of the things that neural networks are really good at, and that's vision classification or image classification, or whatever they call. I mean, what else they call object classification as well. Deep neural networks have also been used in computer vision as it relates to autonomous vehicles. So right here in the bottom left-hand corner, you can see a deep neural network actually predicting the trajectory of the vehicle. So I think if I'm correct, I think the blue line is the actual, what it should be, the ground truth, and the green line is the actual prediction by the machine learning. So this is actually a regression problem. So you have now deep neural networks being able to classify objects, and you have deep neural networks being able to control vehicles as well through vision. Deep neural networks have also been used in natural language. So over the years, if you were like an early adopter of speech recognition, you may have said in the beginning that, gosh, these speech recognition systems suck, which they did. But in the recent years, you have seen a great improvement, especially with things like Google, Siri, and I think Dragon Naturally Speaking. And all of this is due to deep neural networks. So they've also been used in question and answer bots. So if you ever interacted with a chat bot on Facebook or any other service, those are usually powered by deep neural networks. So deep neural networks, just like in vision, have also been used in natural language and basically achieved like some sort or close to human-like performance in some data sets. Deep learning has also been used in analytics and decision making. And in this chart over here to the right, this deep neural network is also being used to predict crop yield analysis on this map. So I guess the point, or what I would want to say to summarize, is that because of deep neural networks, we have been able to get closer to human-like performance in some data sets or areas. And I'll pause right there because I hear someone typing. I don't know if there's another question.
There's one more question. Is there a common standard or examples for deep neural networks that the community can find? Have to reinvent the wheel and research something new like websites or API. Common standard example for utilizing a deep neural network.
Okay. I'm gonna take I think that yes, it is a standards. I mean, and it's standards in both the software that you use and also the data that is available. So for the software that is being used, you can actually, it's a lot of different frameworks and examples already are publicly available on websites that you can download. One of the most famous examples is called the MINST data set, in which you can use deep neural networks to actually recognize handwritten characters. So that's usually like the example everyone starts off when first getting into AI and deep neural networks. As far as data sets, it's plenty of data sets available if you want to go out there and train your own deep neural network or machine learning, along with the step-by-step instructions. So to just summarize that point, yes, there's a lot of instructional information out there that can that can give you a step-by-step guide on how can you deploy and develop a deep neural network. Okay. All right, so those were examples that we see in, in computer, natural language, and analytics and decision making. But how can we actually apply that to education? And in this section, I just want to kind of go over some use cases that I'm familiar with and also maybe present some new ideas. So the first thing in admissions, so AI is actually now being used to review college applications. Not only in college applications, it's also being used to interview people in industry. In 2017 report found that 33% of the companies that responded to the survey already use some form of AI in their hiring process. And it's crazy that this is happening because just yesterday I read another article that actually said colleges are starting to prepare students how to be interviewed by an artificial intelligent agent. So not by a human, but by a machine learning agent that will ask them questions. So, this is pretty prevalent now. I think this will be the way the industry goes towards. So we're using it basically in industry. We also will see it in college pretty soon. I mean, if not already being used in some colleges, I know it's being used in some colleges. So the purpose of the AI to automate the review of college applications was to be able to evaluate the candidate through interview questions, game and video analysis, including audio, the tone of the person, and speech patterns. So it's just not answered. I guess to summarize this point, it's just not how the response that the person might give. They are actually trying to create agents that can mimic human-like behaviors and that they can interpret the tone, the pitch, and maybe the body language of the person that's actually being interviewed. And all these are human-like traits of an interviewer. So those are things that that are on the, I guess, are coming in the future of actual interview processes. So the reason why they want to actually use AI in these things is to bring in the best candidates faster and more efficiently. But one of the challenges with this is bias. Even though they say they're trying to prevent bias, you're also introducing bias into the data set. And we will actually talk about this in a little bit. So one example I know of that's actually being used in admissions is an example called Applications Quest, and it was developed by a researcher at the University of Florida, Juan Gilbert. So Applications Quest is just basically a clustering algorithm that measures the difference or the similarity between college students. And the underlying concept behind Applications Quest is to make the applicant pool of a university more diverse. So, and they do this through actually the clustering aspect. So you would choose a student, like if I was to cluster on age, gender, race, the type of school they went to, and other factors, the way I could actually make that the pool of people who were actually accepted into the university more diverse is that I would actually choose a student from each cluster, and that will almost guarantee diversity within the admissions process. But there are also concerns with emissions and using machine learning. And in machine learning, one of the, I guess, a famous phrase is garbage in, garbage out. When we're dealing with actual supervised machine learning, one of the issues, I mean, one of the things that we have to do with supervised machine learning is actually have a training set. Or remember what I was speaking of earlier, we had to have a set of observations. And if those observations that we have collected have any types of, any types of biases within them, then the machine learning algorithm will actually pick up on those subtleties and actually be biased itself. So an example of this is Microsoft. They created a chatbot based off of Twitter comments. So when they actually deployed their chatbot, they were shocked because the chatbot ended up a racist because they actually traded on Twitter comments. So, I mean, what you have to be careful of when doing stuff like emissions or interviewing or doing machine learning for some kind of selection criteria is that you have to remember garbage in, garbage out. If you give it bad data, it will act on it. It will basically mimic or imitate bad data.
Nancy.
Oh, okay.
So emissions, it can also be used in assisting students in completing the applications for financial aid and other applications for college. So imagine if you had an intelligent assistant like Siri, in which students can ask, well, how do I fill out this FAFSA form? Or how do I fill out this form? And then Siri will be able to guide or direct them in how to do that. So that's for admissions. Now, once the student is accepted, how can we actually use AI in the classroom? And we can do this through intelligent tutoring systems. So an intelligent tutoring system is basically a machine learning or AI agent that basically can generate problems and generate feedback for the student. And it allows for customized instruction and feedback. And so it's basically a personalized learning system. One example of this is the actual Georgia Tech virtual teaching assistant. So at Georgia Tech, they actually created a TA that actually interacted with the students. I think it answered the student questions or maybe helped them through some kind of certain assignments. But the students went the whole semester working with the TA, not knowing it was an actual artificial or machine learning agent. So that was a very good example of how an AI system can be used in tutoring. And I don't know if this will play. And this is an early example of an intelligent tutor. Well, not an early example, 2008. Well, it won't play. Yeah, I can. So basically, this is an auto tutor demo, and the student can ask questions to the tutoring system, and the system can basically respond in natural language. So this is an example of how intelligent tutoring systems can actually be used. So we have intelligent tutoring systems, but we also have adaptive learning systems, which equal personalization. So it's a similar type of system, but it can determine and adapt to the needs, styles, and level of the students. So that's the difference between, usually people confuse them and they are very similar. So an adaptive learning system is usually found within an intelligent tutoring system, but it's only adaptable if it can determine the needs of the actual student. And to do this, machine learning can be used. An example of this is done by a researcher at Duke University, Shani Daly. She actually created a system called Engage Me, in which they actually put, they put wearables on students to actually measure their physiological signals. From these physiological signals, they can then be used to adapt the learning to certain students' learning styles. So I think that the actual future of learning in the classroom is some sort of adaptive learning system like EngageMe that includes eye tracking, body pose, and voice features, along with an intelligent tutoring system. Outside of just the classroom, I mean, you think of just like in the classroom, but intelligent tutoring systems or adaptive learning systems can also be used to actually train people. So they can be used to give people to teach new skills to workers and other people in the classroom. And that's what my research in when I was getting my dissertation kind of focused on was actually training nurses how to interview pediatric patients. So we created basically an intelligent chatbot system where the nurses could ask a patient a question and the patient could respond with the answer. And if the patient didn't respond with the right answer or an appropriate answer, then the nurse would realize that they were actually asking the wrong question. So this helped them with their actual interview skills. So what are some of the limitations on training systems? So they're only focused on speech. They cannot interact with the environment such as tools, and there's no measure for engagement, and it's static as it relates to learning. So once again, the suggestion is to use gestures, augmented reality, EngageMe, and adaptive learning to create a more interactive system that can train people for different skills. And before I move on, is there any questions? Okay, so I just saw.
This one says, if you provided online training, could adaptive learning system be used to provide more or less difficult material to help with the student's progress throughout the course?
Can you repeat that one more time?
Yeah, it's worded, if you provided an online training, so similar to what we do with educated workforce, could adaptive learning system be used to provide more or less difficult material to help enhance the student's progress throughout the course?
Oh, yes, for sure. So definitely. So the way I would imagine something can adaptive learning be used in that situation, yes. If you actually had a data set of past people and the problems, and then you actually collected data from them and had them, I guess, say, what are some of the challenges that they had in working out this material, or should you, or give it like provide suggestions on, okay, maybe you should have included this problem or not included this problem. Then you could use basically a machine learning approach and take the data from that training set to train an adaptive learning system to personalize the lessons to the student or the person learning at that time. So advising so another area in which AI or machine learning can be used is an intelligent assistant similar to Siri for actually advising. So this will actually reduce the amount of time the student spends with the advisor. So imagine instead of going to my advisor's office and asking out, well, do I have to actually take this class to graduate? I can instead ask Siri that same question and they give me an answer. It can also provide course recommendation system. So similar to an internet ad recommendation system, which presents an ad based on browsing history. So if we created a machine learning application that actual knew what previous classes that you have taken and looked at what other people who had taken similar classes and basically predicts what classes you should take next or recommends what classes should you take next based on other people or other students taking similar classes. So imagine basically advising as a course recommendation system similar to internet ads. Next, performance assessment and evaluation. Can machine learning actually be used to to evaluate students? And our answer to this is, of course, I mean, this is definitely already happening at a larger, at an institutional level. So, now industry uses big data, but universities, high schools, I would even assume middle schools can also use data that they're collecting to actually identify problems. So if I can identify potential students that could be failing, and that would be one way in which I can use machine learning or big data. I could also forecast future performance. So what would be the average GPA of the student before the next semester? So if I have enough data, I can actually do this. Or I could find new opportunities, which new course or programs should be added based off of big data and machine learning. So machine learning can be used for the analysis of performance and evaluation of higher learning in a sense. So that's how it can be used basically in the classroom. That's how we can apply machine learning to education, advising, evaluation, um, all kinds of tutoring, teaching, all of it, all kinds of areas in education. But one of the, I think another area that we should also focus on is machine learning is definitely coming. AI is definitely coming. It's nothing that we can do about it. As industry, this is the way the industry is shifting. So, how do we not only use machine learning to teach AI or to, I mean, use machine learning to help in the classroom, but how can we actually prepare students for the AI or machine learning revolution? So these are two quotes that I like to put on slides. The last 10 years have been about building a world that is mobile first. In the next 10 years, we will shift to a world that is AI first. So this is from the CEO of Google. And from another quote is, it's hard to overstate how big of an impact AI is going to have on the society over the next 20 years. So not only how can we use AI in education, but how can we prepare our students for the AI revolution? Or how can we prepare even current workers for the AI revolution? So we see AI in these areas already. Manufacturing is already being used in automation. So workers need to know how to program robots or how robots work. It's also being used in the medical field. AI can already be used to diagnose cancer or lung cancer. It's already been shown to do that. It's also being used in the automotive field in self-driving vehicles. So this is a video of one of the videos that my students put together on how we're actually using AI in autonomous vehicles. So AI is already being used in these areas. So where you may have had people actually working in the shop floor, those jobs may disappear. Where you might actually have people who are nurses who would do this by reading the x-rays, those jobs may be disappearing. And where you might have also had people who were taxi drivers or some kind of chauffeurs, those jobs could also possibly disappear. And because of those jobs are actually disappearing, we actually need to prepare the next generation of skilled AI workers. So in a survey done by Ernst & Young, 52% of executives believe AI will have a positive impact on job creation. So it's coming. About 1/3 of the respondents say that with the implementation of AI, more jobs will be created than lost. That's what they believe. 20% anticipate that AI will even create a surge in new jobs. With that being said, all that cannot be possible. We can't achieve that unless we actually have the skilled workers to do that. 80% say there's a lack of talent to fill these positions. 48% a lack of managerial understanding and sponsorship is an issue standing in the way of successful AI implementation. So, how do we actually prepare students for the AI future? What skills do the students need? One of the skills, programming. Another skill is math. So Cal 1, 2, linear algebra, and statistics. then you need to know what tools do students need. So these are the tools that I kind of spoke of earlier. These are available on the internet, and these are basically frameworks in which you can use to develop machine learning and artificial intelligence systems. So there are libraries, programming libraries. But the issue is we're actually creating a digital divide. So if you're not fortunate to go to a university that actually teaches this, or say for instance, you're already out in the workplace, how do you actually get the skills to prepare for this AI future? One of the ways is through a nano degree. But even the issue with nano degrees is that a nano degree in machine learning can cost up to $999 a flat fee to get a certificate that's going to say that you're an AI engineer. For some people, that's not obtainable. So we have to think of ways in which we can actually teach AI to the generation that maybe lose their job or the future generation. And also, one of the other issues is that even with some of these courses, is that it requires a prerequisite that some people may not have. So, my big idea how can we actually give people who don't have the skills or in under resourced communities an ability to learn AI? And I like to say this is kind of like a AI to solve an AI problem. So it's Inception. It's a dream within a dream. So how can we use AI? I want to see, can we use AI maker spaces for teaching AI in under-resourced communities? And in this chart, we have students. They will actually build and code robotic systems. And from these robotic systems, say for instance, I want to code a robotic system to make a right turn. From the output of this system, the students may code it, do it in whatever language they learn, and then in the end, the robot, instead of making a right turn, it actually makes a left turn. From there, how can we teach the student what they give them feedback and actually show them what they may have done wrong? And that's when an intelligent tutoring system can be used to provide feedback, suggestion, and hints, and it can also be used to generate new coursework. So basically, overall, we would have students learning from students learning AI from AI systems. And that's my big idea. And with that, I'll take questions.
One question, how easy is it to determine if an AI algorithm is not working correctly? Seeing that AI will be more prevalent in the workforce, it seems logical to have measures like this in place since AI automates the things around us. This is in regards to the garbage in, garbage out, Microsoft chat box you were talking about.
Right. So that's a very active research area right now, and it kind of goes into two areas. A lot of people are trying to solve the bias within AI, especially in the medical field, because a lot of research has been done recently. Well, actually, a hospital just got sued like last week because they realized one of the AI systems that they actually deployed was biased. So this is a very active research area in which people are trying to solve. I mean, the best way to actually solve bias within your AI system is to make sure that the data that you're collecting is diverse. So you need to actually collect the input data from a diverse set of people. The other thing was, can you repeat the question?
How to determine it's not working correctly.
Oh, how do you actually determine that it's not working correctly? The simple, I mean, I guess the first answer would be you should be able to tell from the output, but sometimes it would be hard to distinguish from the output if it's working exactly how it should be. But another active research area is something called explainable AI, in which the artificial intelligence system can actually explain why it made certain decisions to a human. So that is one research area that's actively being explored because I guess the issue with machine learning, especially deep neural networks, is that it's kind of like a black box. You just give data to it, and then it just outputs some kind of function or some kind of answer. So people are trying to actually change that black box and make it more transparent. You point to reference. Oh, it disappeared.
Can you point to references on work being done on monitoring the integrity of AI systems used for evaluation and assessment of students? We can follow up.
Yeah, I can follow up with them on that. I can look to see if I find some articles. Yeah, I'll send that out.
Are there any other questions for Jerome? Remember, you feel free to unmute your mic and also just talk directly with them as well if the chat is not appearing on your screen.
All right, well, thank you. Have a good one.
All right, thanks everybody. And again, we'll send out more information about the next webinar, which will be in mid-February. And that will be on emerging research studies in AI. So again, this webinar was recorded, so we'll post that on our website, and you can always reach out to us with additional questions. And for the one about the student evaluation, we will follow up with you on an answer shortly. So thanks again, everyone, for your time, and have a good afternoon.